everyone, this is Ms. Smith from Sinclair Elementary, and I'm here today to work with you on a very, very important math topic. A topic that you'll see over time that mastering the skill will really help you as not just as you grow as a math student, but as you grow as a person into adulthood and into a person that knows how to make decisions and good, wise decisions. So if you'll notice above me, I put a little title for today's session, which is estimation. And so we're going to talk about how estimation comes into our lives and how to use it, how to use all the different ways to estimate and what it actually does in real life. So look above me, and I wrote, how can estimation help us? And just to remind you, during this entire session, I have two important pieces of what we're going to be using estimation for today, and that's for problem solving and decision making. So why we do estimation is not to pass tests and not to show off our math knowledge. It actually has a real purpose. And if you look around and listen to your parents or other adults around you, you'll notice that they use estimation all day long to make all kinds of decisions very quickly. So that's why it's pretty exciting to take a look at how this works in your life. So once again, our topic is estimation, and we're going to use it specifically as it relates to problem solving. And in our case, it's going to be some word problems. So the first thing I'm going to do is introduce you to 3 different ways to estimate, and they're all unique in their own ways, but get us to where we want to be. Go ahead and make sure you have something to write with and a notebook paper or a journal, and you will follow along with me, and you can pause when you need to. Always rewatch videos if it may take you more than once to learn how to do this. So go ahead and start by writing down estimation, and I'm going to explain to you using a definition, the official mathematical definition of what estimation is. I'm going to pull down my chart and you can copy it down in your notes. Okay. Here you can see in orange, I want you to write this down first. In this orange section, it says to estimate or an estimate. You can use it as a verb or a noun. An estimate is an approximate number close to the actual value. Approximate number close to the actual value. So it's not the exact number, it's a close to the actual value. So instead of using a number like 42, we can say 42 is approximately 40, right? Because that's an easier number, 40. Or some people might even say 50. The point is, it's not exactly 42. So estimation takes a closer number that's easier to work with, okay? So why do we use estimation? So I always talk about the purpose of it. Think about it. When you use a number that's not the exact number, just close enough number, it's quick, easy, and convenient. And convenient means, if you don't know what that means, convenient means that it's handy, like it's nice to have. Like if you can calculate something very quickly and make a fast decision. So like I mentioned earlier in the session, it's for fast decision making. So today I'm going to break down some word problems because we're going to do word problems. And I'm going to talk about 3 different ways you can estimate. They can all give you a number close to the actual value, but they may not be the same estimate, but that's okay. You're just trying to make a quick decision based on the information you have. So the 3 different ways we're going to learn to estimate today are 1, front end estimation. It kind of sounds like the front end of a car, right? Like that's what they call the front part of your car is called the front end, not your car, but your parents' car is called the front end. There's also compatible numbers, which are numbers that are related. And last but not least, rounding, which you've already done this year. So you're gonna use rounding to help you with estimation. All 3 of these ways are correct. I'm going to say that again. All 3 are correct. It doesn't matter which one you use unless they specify in the problem, but all 3 of these will allow you to make a fast decision when you're dealing with numbers. So let's give it a try and look at some examples in real life. But first, I'm going to walk you through the 3 different ones. Okay, so you should be taking notes and writing down what I write down. Front end estimation. This is a really unique one. A lot of people always ask me, wow, is that even accurate? Well, front end estimation is it's the quickest one because you just literally take the front end number. So let me write down front Let me get a better pen because that one is not cooperating. Front end estimation. Okay, and as I said before, think of it as like the front end of a car. Let me draw that. I can't really draw a car, but I'll try. Here are the wheels. You get the point. Here's the lights. So the front end of a car, that's pretty bad, but that's okay. So the front end of a car. So you're gonna take the front, actually let's draw it this way because the car's going this way. Okay, the front end of the car, he's driving this way, okay? So the front end estimation is where you literally take the front end of a number. So let me show you what I mean by that. If I wanted to add 45 plus 23, okay, watch what I'm gonna do. I'm gonna take the front part of the number, the largest place value. I'm gonna take the largest place value, the 4 and the 2. Those are in the front of this number. So 45 becomes a 40 because all I did was take the front number. That one I left as a 0. I'm just gonna call it a flat 40 because I'm only using the front number. The 2 is the front number, so I'm just gonna add it like that. I'm just taking the tens value in this place. So instead of 45 and 23, I'm using the front end of the number only, and I'm gonna say 40 plus 20 is 60. So my estimate using front end estimation is that 45 and 23 is about 60 because I just used the front end of the number. It's that quick, easy, and that convenient. Let's try another one. I have one right here that you can write down in a moment. It's subtraction. So let's keep going. How about 892 minus 379? So once again, I do not care about any of these numbers. I only care about the front end of the number. Front end, front end. So instead of 892, I just have 800 because I only care about the front number. Instead of 379, I only care about the front number, so I will have 300 minus 300. So I rewrote this problem using only the front number. And in this case, 800 minus 300 is 500. So my estimate is 500. You can go and do this to see how close your estimate was. So since this one's a great example, let's go ahead and do that and see how close our estimate was. But front end estimation is the quickest one because you're only worried about one number. But let's try to get the actual answer to see how close we got. So we're gonna subtract the exact number now. 2 minus 9, you can't do that, so I have to borrow and turn this into a 12. This turns into an 8. 12 minus 9, 2, no, not 2. 12 minus 9, 3. Almost forgot what 12 minus 9 was. 3. 8 minus 7 is 1, and 8 minus 3 is 5. So our actual answer is 513, which is pretty close to 500. So in this case, front-end estimation was very quick and easy and very handy. So if I'm trying to make a decision about money, I can do it pretty quickly, right? If I know that I have $892 and I just spent $379, using front-end estimation, I would be able to see that I would have around about $500 left, which was pretty close once we did the work. So that is called front-end estimation. Now, compatible numbers is a little bit different. Not too much different. They all are similar. Compatible numbers. And if you don't know what compatible means, it actually means similar or likely to work together. One example I gave to my students in class today was that sometimes you may have pets. You may have more than one pet in the house, and say for example you have 2 dogs, and then somehow you rescue another dog and you find yourself in your house with a 3rd dog, and the dogs start fighting because they don't like the new dog, and over time things don't get better. That means those dogs are not compatible. They're not a good match, right? They just don't fit together well. So compatible means something that fits together well and is a match. So typically with compatible numbers, we look for math facts, something that's already established. So let me show you what I mean by that. Okay, so a number like I'm gonna go ahead and use a simple one. So if I wanted to divide 423 divided by 12. Actually, let me not do 12. Erase that. Let's do 22. Say, for example, I found myself in a situation where I came across this division problem. I would have 423 divided by 22. But I don't want to do that with an exact figure. I want to use estimation so I can quickly come up with something that would make sense. And a scenario might be, I have a book that's 423 pages, and I want to know if I read 22 pages a day, like about how long, because I know about how fast I can read, right? So if I know I can read about 25 pages a day, but it's actually 22, I want to know about how long it would take me to read a book. So this is where a real life scenario would be important. So using compatible numbers, I'm going to take a look at the relationship between these numbers. So I have a 4 and a 2, which are compatible, and I know that I could divide those. So I could say that a 4 and a 2 are similar. So I could estimate 423 to be 400 instead of 423, divided by a compatible number with 4 that I'm dividing by, which would be 20. So let me go over that again. They're compatible because 4 and 2 are related to each other, right? 2 times 2 is 4. 4 divided by 2 is 2. So they're a match because they're a math fact together. So that's why I'm choosing those numbers. I could also, okay, so let's do that. 400 divided by 20. 400 divided by 20. So I'm going to see, does 20 go into 4? No. But 20 goes into 42 times, and I would get 40. 40 minus 40 is 0. Drop the other 0. 0 divided by 20 is 0. 0 times 20 is 0. So I can see that I can estimate it would take me about 20 days to read that book. But once again, I'm not getting the exact number. I'm getting a number that is close to that number. Okay? I'm going to move this so you can see the exact things I'm working on, and I'll move it back in a moment. Okay. So that's compatible numbers. So that's one example. And I'm going to move over here because I want to do a couple more with you. I want to show you this exact example and show you how you can use another compatible number with estimation. There are more than one. There are multiple ways you can estimate. Eventually, you look for one that's most reasonable. So let's just do this one again, but with different compatible numbers. Oh, 22. Excuse me. So, same thing as over there. 423 divided by 22. So this time, instead of using 400, what if I did, what if I said this could be 500, like say I just went ahead and gone up, divided by 30 or 25. I could say 25 because I know 25 is compatible with 50. Maybe somebody sees it that way. Compatible numbers have to do with how you see the number, okay? So I know that 25 goes into 50 2 times, and I have to just add the other 0. Okay, let me show you again, if you can't do that in your head. If you did 500 divided by 25, okay? So does 25 go into 5? It does not. But it does go into 50 because 2 quarters make 50 cents. Use your knowledge of money. 25 and 25 is 50. So 2 times 25 is 50. 50 minus 50 is 0. Drop the other 0. Does 25 fit into 0? 0 times. So my answer again is 20. But look how interesting this is. I got the same estimate using 2 different compatible numbers. It's just a matter of which 2 compatible numbers you see within that division problem or multiplication. So compatible numbers are very useful. And last but not least, the third way is rounding. And that's one that you're probably most familiar with because you've been rounding since 3rd grade. So rounding is simple. You just round the number to whichever place value you feel like is most reasonable. And rounding is super useful when you're estimating money because it just makes sense. If you have, depending on what type of dollar bills you have with you, if you have multiples of 10, 100 if you're lucky, etc. So rounding is just based on your own estimate of what you think you should do. Okay, so let me show you what I mean by that. And after I finish showing you the third one, we're going to go through some really great examples that help you learn this. Okay, so rounding is using a specific place value. Okay, so rounding is, as we've been rounding all this time, you're going to a specific place value. Sometimes it's the tens, sometimes it's the hundreds, sometimes the thousands. It's just depending on the scenario. So let's think of something. Let's try multiplication this time. If I had 418 times 32, well, I want to just estimate a solution to this. I do not want the entire problem solved with exact values. So rounding to the nearest, to the largest place value, here I would see that the 1 is not large enough to bump it to the next higher up value. So 418 would become 400 and 32 would become 30 because 2 does not bump it to 4, is not large enough to take it to the next place. So then instead of multiplying these numbers, I can just multiply these. So if you know about column multiplication, which you should by now, you can drop this 0 just as a bookmark because they'll all be zeros. And then you can continue on. 3 times 0 is 0. 3 times 0 is 0. 3 times 4 is 12. And your answer would be 12,000. So that was very quick, easy, and convenient using rounding to the largest place value. Okay? Let's try another. If you were dividing, what if you were dividing, for example, 725 divided by, actually that's not a good one. Let's do another. Let's do 228 divided by 19. Okay, so take a look at that. We want to divide 228 divided by 19. But I do not want the exact number because today we are estimating. So I'm going to estimate both of these numbers into something that's easier and faster for me to use. So using rounding to the largest place value, I'm going to do the same thing I did before. I want to go to the largest place value. So this 228, I'm going to look at the 2 and I'm going to see that's not large enough, so I'm going to let it rest and leave it at the lowest place value. And then the 19, if I'm going to the highest place value here, the 9 bumps this to a 2, so I get a 20. So now, using rounding, instead of doing this problem, I have something much easier and faster to get the approximate value. So 20, does 20 go into 2? It does not. Does 20 go into 20? It sure does. 1 times 20 is 20. Gives us a remainder of 0. Drop the 0. Here we go. 0 divided by 20 is 0. 0 times 20 is 0. And our answer that was fast and easy was 10. This is a great time to pause if you need to review those 3 different ways that I taught you how to estimate. Because next, we are going to practice with real life problems that help us make decisions. So pause if you need to go back because I'm going to move on to actual problems. So I have about 10 minutes left, and in the next 10 minutes, we're going to work through each of these using our 3 different estimation techniques. So as always, I don't like to overwhelm you, so I like to fold my paper so that you only focus on one problem at a time, okay? So take a second to read this one. Okay, I'm gonna read with you. Hopefully you read it. Mr. Railsback is planning to pay off his credit card balance of $4,839 within the next 12 months. About how much money will he need to pay each month in order to pay it off? Okay, let's think about that again. So, our question, about how much will he need to pay each month to pay it off? Okay, how many months? 12. So conveniently, they made this 12 months, which is a year. So this is a person who needs to pay off money they've already spent. So that's what it means by credit card, in case you guys don't know that. When you use a credit card, it doesn't just get paid for, right? You have to pay it back. Using a credit card means you're borrowing money. So you have to pay it back. And most importantly, you have to make a plan on how to do that and don't keep adding to the money that you've already spent. So we're gonna take this number and we're gonna think about what we're gonna do with it. But we are definitely not calculating the exact amount. We're gonna try different ways. So if he's got a large sum of money, we talked about this with long division last week. If he's got a large sum of money and he's trying to figure out how much to pay off during a specific equal amounts of time groups, we know we're doing division here, okay? So I'm gonna start by using front end estimation first. So let's try front end. I have 4,000, I do not like this pen. Sorry about that, y'all. 4,839 is how much money he has that he owes someone, and he wants to pay it off divided by 12 months. Each month, I'm gonna write each under here. Each month, he's gonna pay money. So each of the 12 months, month 1, month 2. So he's trying to figure out how much he should pay every month so he can pay this off. So this is why we have this expression. This is his total to pay off divided by those 12 payments, okay? So hopefully you're there with me. Now, using front end estimation, if you recall, this is the one that's the fastest and maybe not the most reasonable depending on the situation. So let's just look at it. We're only going to use that front number. So the 4,839 becomes only 4,000 because I'm only using the front number. Using only the front number, the 12 becomes a 10. So now I'm going to do 4,000 divided by 10. 4,000 divided by 10. So then I'm going to go digit by digit. Does 10 go into 4? It does not. 0 times. You can put a 0 if you want. So now I'm going to move to the next place. Does 10 go into 40? Yes, 4 times. 4 times 10 is 40. 40 minus 40 is 0. And now you'll see you continue dropping zeros, and all that will do is yield additional zeros. So your answer is 400. Using front end estimation, it will be about $400 per month. So that was front end. Now let's try compatible numbers. And remember, compatible numbers are using numbers that are related to each other and quick and easy to do math with. So same thing. We're going to look at this. We have, I'm going to rewrite it so you can see what I'm going to do differently. 4,839, same thing, divided by 12, same thing. But now, instead of using front end estimation, I'm going to look at these two numbers, the divisor, which is 12, and the dividend. So the large amount plus the number of groups. And I'm going to look at those and I'm going to look for a relationship. And if you see what I see a relationship between the 12 and the 48. They are compatible because 48 divided by 12 is 4. So instead of turning this into a 4,000, I'm going to turn it into 48 and turn those into zeros. So I'm getting closer and closer to my estimate. So now I'm going to leave the 12 the way it is because it's already has a relationship. It's compatible with the 48. So 4,800 divided by 12. And once again, I chose these numbers because they're compatible. So you would have, does 12 fit into 4? It does not, but I know it fits into 48. 4 times. 4 times 12 is 48. That gives me a 0, drop a 0, and here I am again in the same position where if I just continue with the zeros, I get a nice even round 400. But look at that. Using both of these estimates, I got the same payment. So it doesn't matter. They don't even have to be the same. One of them could have been 500. The point is you're trying to come up with something, some approximate value, okay? And then if you used, let me erase a little bit of this. If you used rounding as your third one, rounding, it would have been similar. It would have been a similar outcome. It's just whatever is comfortable for you in that moment. 4839 divided by 12. So if you were to round this, for example, you could have rounded this all the way up to 5,000, and you could have rounded this down to 10. That's fine. That's rounding. And then you would have done 5,000 divided by 10. Does 10 go into 5? No. Does 10 go into 50? 5 times 10 is 50. And when you continue dropping those zeros, you're simply just adding on place values, and your answer would have been 500. And in this case, using rounding, he would have paid $500 a month instead of the $400 a month that we got in the other two. And that's not a big deal because number one, they're close together, and number two, paying off more rather than less is never a bad idea when you're paying off money that you owe. So those are the 3 ways to do the first one. Last one, guys. You're doing awesome. Take a look at this one while this one was division, and this one's going to be multiplication. So take a look at that while I get ready over here. Okay. Stone Printing Company prints flyers each week. They packed 207 flyers in each small box, and I drew this for you like with a little smaller box, 443 flyers in each large box, and Stone Printing Company, same place, sent out 23 small boxes. So notice I put the orange with the orange, 23 small and 18 large boxes of flyers last week. In all, about how many flyers did they send out? These two words should be switched, my fault. About how many flyers did they send out? That was for the whole week. Okay, let's read again. So we have a company that's printing flyers, okay, and they have a box that has a certain amount of flyers. But once again, we're estimating, so we're not going to sit here and calculate all this out. So in less than 2 minutes, we're going to do all this because it's fast, easy, and convenient. Okay? So using front-end estimation, I want you to take a look at the information that we've been given. In math problems, always organize your data. We're talking about 2 different boxes, small and large. You can abbreviate, that's fine. Small and large. Let me make that a little darker. Small and large. How many flyers do we have in a small box? 207. And a large is 443. I got all of that straight from the answer, from the problem, okay? So that's how much is in each box. They also said that they sent out 23 of these, so I'm going to put times 23, and 18 of these. But these are my exact numbers. I do not want that. Thank you for the information problem, but I'm trying to make a fast decision. I don't have time to sit here and do all this math. I need to hurry up and know how many flyers, about how many they sent out last week. Someone's asking me to make a quick decision, and I do not have time to do all this math. And that's where estimation is so important. You make fast decisions because you do fast mental math with that. So with small, instead of 207, I'm going to use front-end estimation. So my 207, using the front, becomes a 200 times the front of this one, 23 boxes of those, but I'm only saying 20, 200 times 20. And hopefully you know this trick, but you take that front number, 2 times 2, which is 4, and then you add the zeros. 1, 2, 3. 1, 2, 3. There you go. 4,000, small. That was small. Now with large. Front end estimation, I have 443. Let me do this in a different color. Right here, I'm only using the front number. I'm going to move it and I'm going to make it 400. And then I have 18, right? I don't want to use 18. I'm using the front of 18. That's 10 times 10. Okay, I'm going to multiply. I'm going to get 4. 1, 2, 3 zeros. 1, 2, 3. I got 4,000 there. And in all, so I'm going to add 4,000 and 4,000. And in all, I can answer somebody's question quickly and say they sent out about 8,000 flyers. Look how fast that was. So that was front end estimation. If I used compatible numbers, it really wouldn't matter because they would be similar. If I used compatible, I would still use those numbers. I would still use 200 times 20. And in fact, this problem, I would use the same thing for rounding. You could round up or down. Like watch, if we did, let's do rounding. Let's try rounding because I think that'll provide a great example. If I used rounding, I would take the 207 times 23 for small. We're only doing small first. And I would say that 207 rounding to the nearest, to the largest place value, I would say 200 times, same here, I would say 20. So for the small, I would have 4,000 again. But for the large, look at the large. 443 times 18. This is where you'd have a little bit of a difference if you used rounding instead of front end. So for the large, I would still have 400. But look here, front end said times 10. But rounding or compatible numbers would tell me that 18 is almost 20. So I would want to take that into consideration. And then I would have 8,000. And then my answer would be quite different because it would be 12,000 flyers, not 8,000. So back to that reasonableness factor is that you have to look at the scenario and determine which one of these estimation strategies makes most sense given the decision that you're about to make. Very important. Front end, compatible, or rounding. Fast decision making, guys. This lesson feels like it flew by. It did, because it's a lot. But when you work with estimation, it will make you a quick decision maker. It'll make you a problem solver. It'll help you understand life and make good, smart decisions. So keep working, keep estimating, and I'll see you guys next time. Bye.